Okay, we're going to first look at this idea of what do we mean by a theory or a model, and I'm going to draw some lines on the screen here. I think I get this right. I think it goes sort of like this, and then like this, and then this is over here like this, and there's a little space down here like this. And what are all these lines? What do they represent? Well, we could sort of say that Dawson College is at this point here. And at first you might just say these are random lines, but this in fact is a map of the metro in Montreal. So when we speak about a theory or a model, what we really mean is it's kind of a representation of the real world without being the real world. And it's very important to not confuse the difference between the two. A model or theory is symbolic, and it's quite distinct from the real thing. Very important when we're using theories that we use an appropriate theory or model for the problem at hand. The map on the left is a very simplified map of the metro. The one on the right is much more detailed, and it has bus routes and so on. There's a monk that lived in the 14th century, William of Ockham. It's referred to as Occam's razor, which is that the best model or theory is one that is the simplest, or the best explanation for a phenomenon is the simplest one. That's not always true. Occam's razor, I sometimes refer to is keep it simple, stupid. We do this frequently in economics, is that we simplify things down to eliminate all of the various outside factors that are confusing so that we focus precisely on what we want to do. Models generally come in three different styles. Sometimes they appear as a picture or a graph or a map, such as the ones we're looking at here. A model or theory can also be story, a narrative, word description. I'll do that quite frequently in this course. And then the third way of showing it is a series of mathematical equations, which is typically how more advanced courses in economics are taught. In fact, these last two are very similar. They, in effect, are the same thing. Mathematical equations, just more precise. But as I say, a lot of students find math difficult to do, so I won't be doing this. And in fact, in this course, I'm going to try to keep the number of graphs, if you want to call them maps, as small as possible. But I will be presenting a brief graph. One of the brief graphs we'll be using in this course. I'll present it in the lecture today. Now, the graph or model that we're going to be using is going to explain what is sometimes referred to as the textbook definition of economics, or the standard economic problem. And that amounts to how we go about choosing when we can't have everything. We sort of imagine it's like when you go to a grocery store, and I do this frequently, I look at what other people put in their grocery cart. Now, I'm going to use this model today also in this lecture. I'm going to use it also to understand two of the key ideas, one of them being opportunity cost and the other idea of what's called rational behavior. But when you go to the grocery store and you're picking the items to put in your cart, that's often confused with the idea, well, how much money do you have? And so people say, I'd like to buy more, but I don't have enough money. Maybe not at the grocery store, but sort of maybe more likely online. The problem with money, I find it confusing, in part because people often don't pay with actual money. They pay with a credit card, which means you can borrow, but then you can't borrow endlessly. You go bankrupt. So I'm going to try and ignore money in this lecture, and I'm going to be focusing on what I call real resources instead. But it raises kind of an interesting point here. Is a better example might be, well, how do you pack? Think about it. If you're going to go on a holiday someplace, how do you go about choosing what you're going to take? And there's no money involved in this because it's the maximum weight you can have in your suitcase. So here's somebody who's very practical about it. I think in international travel, you're allowed to have 22 or 23 kilograms in your suitcase. That's a limit. And what would you take? Well, if you're going to be going to the south, you might take a beach towel or something. And if you're going to a place like England, you probably take an umbrella. But then the key question is, well, what can you fit? And in this case, what we'd say is the scarce resource is the size of the suitcase with a limit of 23 kilograms if it's an air flight. And then you can use technology, like this person apparently, some kind of special skill in order to get everything to fit in. And this is what we mean by the economic problem, is that how do you go about choosing when you can't have everything you want? Sometimes it's not an issue. If you're going to be only going for 1 week, you might just have not an issue being able to fit things in your suitcase. Other people have a problem doing it. But this raises a kind of interesting question. What about Bill Gates, for example? Does he face this problem? He doesn't have to worry about how many suitcases. He flies in his own plane. And if he wants to take more luggage, he can just get another plane. So we'd say then, well, nevertheless, the economic problem or this issue of scarce resources and choice still applies, because Bill Gates has to worry about one of the key real resources in time. He's well aware of the fact that there's only 24 hours in a day, and he has to select or choose how he's going to spend those hours, what he's going to do. And then it's even more problematic in a sense is that he's born in the 1950s. He's going to live for another 2 or 3 decades if he's lucky. So what does he do with this time? So we're all confronted with this problem of scarce resource in the sense of time. But there's other resources as well that matter. For example, the Quebec government. It may seem like the Quebec government can do all kinds of things, but it also has to face these constraints or this difficulty of a scarce resource. If it wants to increase spending on one particular item in the budget, lower tuition fees, or make certain things, services free it has to cut spending elsewhere, raise taxes. People don't like that. Maybe it can borrow, but if it borrows, then it has to pay the money back sometime in the future, which means that some people, younger people often will have to pay the taxes for this. So even the Quebec government faces this textbook problem of scarce resources and making a choice. There are a few things that are kind of interesting, though, where this doesn't really apply. Think of gravity. You can have as much gravity as you want. You don't have to worry about it being scarce, or sunlight on a summer day. You can have as much as you want of that, assuming the cloud doesn't block it. We're going to look at these kind of strange cases later in the course and see what the implications are, then whether economics has anything to say about them. But as I say, I think this definition of economics is somewhat narrow, and economics is a social science, and it's concerned about how people deal with one another. So let's get to our first simple economic model, and I'm going to do this by telling a little story. In Italy, picking a country outside, far away, and it's a bit of a way of telling a good story. I've got this farm in Italy. I'm going to pretend that there's a family, 2 brothers and a father. I assume there's sisters and mothers and so on, but I'm going to worry about the 2 brothers and the father. And I'm going to say furthermore that this family farm, they grow olives and tomatoes. Now, the olives they grow to make olive oil. Now, I'm going to further keep it simple. I'm going to assume that each brother works for 8 hours. They get up in the morning, 9 o'clock, go off into the olive groves and the tomato fields, and they come back at 5 o'clock with whatever they've produced. Now, what are the 2 names of the brothers? Well, obviously one is going to be named Mario. I'm going to call him Mini Mario, and there's going to be Luigi. He's the older brother. Mario is the mini guy, he's the small one. Luigi is the older, bigger, large Luigi. And for this first lecture, I'm going to only look at the situation of Mario. So let's take a look at the case of Mini Mario, how an economist would go about illustrating this problem with a simple model, and I'm going to use it with a graph. There'll be 3 graphs in this course, and this is going to be the first one. So we've got Mario works from 9 o'clock to 5 o'clock, and he can produce either tomatoes and olives. Now, I'm assuming on the farm there's other people in the family, and they may produce other things, but I'm going to keep it simple like Occam's razor, and I've only got Mario, and he's only producing tomatoes and olive oil. So I got our first graph here with the axes. Put X on the horizontal axis, that's going to be the tomatoes he produces measured in kilograms. And on the vertical axis, I've got the letter Y, which represents the olive oil he produces measured in liters. Now, I'm going to say that, just for sake of argument, invent a number here. I'm going to say that Mario goes off, and if he spends 8 hours getting tomatoes, 9 o'clock, he'd be able to come home at 5 p.m., 8 hours later, with 8 kilograms of tomatoes. And I could represent this here by this orange dot, where it shows that he's producing 8 kilograms of tomatoes. That would mean all he does is produce tomatoes all day. At 5 p.m., he comes home with 8 kilograms. Now, if on the other hand, his father, let's say, sends him off to get olive oil, I'm just going to say he spends 8 hours, 9 o'clock, 5 p.m., and he comes home, he's get the olives from the trees, put them through an olive press, and he'd have 4 liters of olive oil. And I show this now by another orange dot where he spends the whole day producing only olive oil. Of course, the next question is, well, what happens if his father says, spend half the day getting tomatoes and the other half getting olive oil? What would happen then? Well, if he spent the first 4 hours getting tomatoes, he'd have a point like this here where he'd have 4 kilograms of tomatoes. And then he'd have the remainder of the day to be able to get olive oil. We'd be able to get 2 liters. And so this point in the middle here, this orange dot, is where he spends half his time getting tomatoes, half getting olive oil. Another possibility, too, is his father could say, well, let's spend the first 2 hours getting tomatoes. So he'd be at this point here. And then he'd have 6 hours remaining, so he'd be able to get 3 hours of olive oil, and he'd be at this point up here. I could keep on doing this with different lengths of time, and eventually I'd be able to put all these various dots together in one single line. Now, if, for example, his father asked him to come back with 4 liters of olive oil and 7 kilograms of tomatoes, like this point D up here, well, the way I've set this whole thing up and designed it is that he wouldn't be able to do that. The maximum he can do is 8 kilograms of tomatoes, but he doesn't do any olive oil, or 4 liters of oil, he can't do anything. So D is an impossible situation. So anything, in fact, outside here is in the impossible zone. If, on the other hand, his father asked him to produce at point C, for example, that means to say he comes back with 1 liter of olive oil and 2 kilograms of tomatoes. Well, he could do that, again, the way I've set this little model or theory up. So that means anything in the triangle at the bottom here is a possible zone. This is where something he could do it is possible. Which means that the orange line represents the dividing or the frontier, the border between what is possible and what is impossible. And in fact, this orange line has a name in economics. It's known as the production possibility frontier or the production possibility curve. Sometimes written as PPC or PPF. So it's the dividing line between the two. I want some quick concepts here, and then I'll finish with my 3 key ideas we can take from this little model. This simple model has three resources. What are they? Well, the first one you could imagine is, well, there's olive oil, or olives, if you will. The second thing is tomatoes. And the third thing is, well, Mario's time, which you could imagine that's the 8 hours. It's his skill. It's his skill for being able to produce olive oil and tomatoes. We have many different ways to classify a resource. Sometimes we call it a good. Good is tangible. Service is intangible. Sometimes it's called a commodity. Incidentally, these are all real. The opposite of a real resource is something referred to as a nominal resource, which would be something like money, which we'll look at later in the course, particularly when we come to macroeconomics. One amongst the various ways to divide resources, one is to divide them into inputs and outputs. So Mario's time would be an input, and these two here are outputs. But it's a classification that can change. For example, olives in one circumstance might be an output, and then they become an input when you're making olive oil. So just a method of classification. I'll come back to this terminology and how we can refer to different goods or resources later in the course. Another way to look at this mathematically, we'd say we've got some kind of we call it a production function. That's this F thing here. And Y is an output. So I could call these Y. There's 2 outputs here in the little graph I've got, the little equation I've got here. There's only 1 output. And then KLEM, this is one of the methods of doing this. These are inputs here. And for example, K would stand for physical capital, L would be labor, E stands for energy, and M stands for other materials or natural resources. In this case, in the simple model I've only got 1 input. It's Mario's time, like his labor, and I have 2 outputs. But we won't be using this kind of these kinds of equations in the course, but I just wanted to show this to you. The technology, well, presumably Mario has some kind of skill or ability. There's the farm and so on, their ability to take olive oil and time and turn it into olive oil and tomatoes. Again, we haven't looked at this simple model. So I've got 3 last points I want to make about this. We assume that a rational individual will always be on the production possibility frontier. Now, clearly, they cannot be out on this zone out here because this is impossible, this region out here. But we also believe that an individual would not be inside. For example, point C. What would that mean? Well, if he came home at 5 o'clock and he only had 3 kilograms of tomatoes and 1 liter of olive oil, his father might say, well, why aren't you bringing back more olive oil? Because in theory, he could be up here or he could be over at this point here. He could come back with 6 kilograms of tomatoes or as much as 2.5 liters of olive oil. But he didn't. Why is that? So what was he doing with his time? And the quick answer to this, well, maybe he was just sleeping under a tree, or he was, texting with his phone. He was doing something else. Let's call it goofing off. And to understand clearly what this means a bit is we'd have to change the model a little bit. So let's add another good. So I've got here one. Think of it this way. There's now 3 possible outputs. You can produce olive oil, or you can produce tomatoes, or you can goof off, either by sleeping or watching TV or just looking at your phone. How would I show that? Well, at present, I've only got X and Y, which are the 2 outputs. If I want to add a new output, a third one, I'm going to have to add a new axis. This would become a 3-dimensional object. In which case now I'd have the 4 over here, I'd have the 8 over here, I'd have, this is the previous budget constraint, but now another possibility is you could just spend Z, let's call this Z, this goof offing, this new way of spending your time. He could spend 8 hours just sitting under a tree looking at his phone and not produce any olive oil or any tomatoes. And that would be at this point here. But of course, he could also do other possibilities, and now I'm going to draw a graph, and the budget constraint now, or this production possibility frontier, would become a plane. It's like a 3-dimensional surface. Well, that's kind of messy, and I'm not very good at drawing, and I'm not even sure this graph looks understandable. So I'm going to take that possibility off the table, which means to say he can't goof off, he can't be doing something else. So the only way he could be at point C here is if he were to actually produce the tomatoes like this point over here and then dump them off a bridge. Well, I don't think people do things like that. I don't think people spend their time producing something and then throwing it away. It happens in life, and economists are very intrigued about situations like this. But in simple terms, we'd say we expect an individual to be on their production possibility frontier, in part because people don't like to waste their time. And sleeping under a tree or playing with your phone or something, that's not wasting your time. You're doing it because you happen to enjoy doing it. So that's the first point. Let's go to the next point of opportunity cost. Let's say the father says, I want you to produce 4 liters of olive oil up here, this point here. And then at 9 o'clock in the morning, he's about to go off to produce the 4 liters of olive oil. And his father, whoops, he said, you know what, we really need tomatoes. We don't need the olive oil. So he says, what I want you to do is go down to this point here instead, 8 kilograms. When the father makes that decision and tells Mary to go and get tomatoes, in effect, what he's doing is, if Mary chooses to produce 8 kilograms, he's going to have to give up the 4 liters. And this is the opportunity cost. And we can see it here graphically, is that imagine that you give up these 4 liters, but then you get these 8 kilograms. So in economics, we refer to this as the opportunity cost. It mathematically is simply the slope of the production possibility frontier. That's the change in y, the change in the vertical distance, divided by the change in the horizontal distance. That's, in this case, it's always going to be negative. You have to give up something to get something else, so it's equal to minus 4 over 8. If I ask a question like this, you can just look at the vertical distance and then look at the horizontal distance, describe that as a fraction or a ratio. And mathematician calls it the slope of the production possibility frontier. Economists call it the opportunity cost. Now, let's go to this last idea, is the concept of introducing some kind of new technology. So let's say we give Mario a ladder. So he's got this now ladder, which means that he can get up into the olive trees faster, more easily. And so let's just say, for the sake of argument, it means his olive production goes up 3 times. But you notice something, tomatoes grow close to the ground, so the ladder is completely useless. If he wants to go out and get tomatoes, he just leaves the ladder at home. He's not going to take it with him. No help whatsoever. So what is the effect of this new technology? Well, Basically, see, if he's going to go and get olive, before he'd only could get 4 liters down here, but now he can get 3 times as much, so he's going to be up at this point up here. He'll be able to produce 12 liters. And I put a 12 up there. Now, if, on the other hand, his father said spend half the day getting olives and half the day getting tomatoes, well, in this case, he'd be able to get, well, at a point like this, which would be 6 liters of olive oil, twice as much he'd get before, and then the remainder of the day, as before, he'd still be able to get his 4 kilograms of tomatoes. So we pick a series of points in between, like before. Father could ask him to go spend 2 hours getting tomatoes, which would be here at 2, and then the rest of the day getting his olive oil. He'd be up at a point like this somewhere, and then we can join these together, and we've got a new production possibility frontier with the ladder. Another way of saying this, new technology, and as we'll see later, new technology is exactly like trade, makes the impossible possible.